Hi Geo, this is Unit 3B, so the second part of Unit 3 is on parallelograms, and this is Lesson 1 from that unit. So today we're going to talk about interior and exterior angles of polygons, and then the rest of this unit will be on parallelograms. But a parallelogram is a polygon. A polygon is just a closed figure consisting of line segments. So closed figure meaning the beginning and the end meet. A closed figure consisting of line segments. So a triangle is a polygon, a parallelogram is a polygon, a pentagon is a polygon. We've already gone over the sides before in an earlier unit, but just to remind you, if something has 5 sides, it's a pentagon. If it has 6 sides, it's a hexagon. I remember that a hexagon has an X in it and 6 has an X in it. An octagon has 8 sides, an octopus has 8 legs, and 10 sides is a decagon. So what we're going to do today is we're going to have a formula to find the sum of the interior angles of any polygon and also the sum of the exterior angles of any polygon. So we'll start with the interior angles. The sum meaning I add them all up. The sum of the interior angles of any polygon is, use this formula, 180 times n minus 2. And n is the number of sides that it has. So if n represents the number of sides of a polygon, so like a pentagon has 5 sides, I would do 180 times parentheses 5 minus 2. That would give me the sum of all the sides of that polygon. If I just wanted to find one side, I would do the same thing, 180 n minus 2, but then I would divide by n. So this is just to find one side. I'm sorry, yeah, to find one angle. So if you just want to find one angle, you do this formula, and this is the sum of all angles. So just to be clear, the difference between those two formulas. So let's just practice a little bit of it here to make sure that you're okay doing it, and then you can try some more tomorrow. So the sum of the interior angles of an octagon. So just make sure I want sum and I want interior because there's going to be a different formula for exterior. So sum means I want them all. I'm going to use that top formula, and interior, and I have an octagon. So an octagon has 8 sides. So I'm going to do 180 times 8 minus 2. 8 minus 2 is 6, so 180 times 6 is 1080. So the sum of all the angles of an octagon adds up to 1080. Now the next one, I want to find the measure of each interior angle. So now I'm going to use that bottom formula. I'm going to do 180 n minus 2 divided by n. Now this is a pentagon. A pentagon has 5 sides. So again, 180, 5 minus 2 divided by 5. So that's 180 times 3 divided by 5. And that gives me 108. Sorry about the dog there. All right, now let's just do exterior angles. These are nice and quick. Exterior angles. So if I'm looking at the exterior angles, the sum of the exterior angles, all right? So the exterior angles are always supplementary to their adjacent interior angle. On the polygons below, let's find the measure of each exterior angle along with the sum of the interior angles. So the exterior angles, like if this angle right here was 40, then the one next to it is 140 because together they form a line. If this angle right here is 79, then the one next to it is 101 because again, they form a line. They have to equal 180. If this is 61, then this is 119. All right, so if I add up all those exterior angles, 101, 119, 140, use your calculator, the sum of the exterior angles is 360. All right, let's do the same thing for this quadrilateral. If this angle is 71, the one next to it is 109. If this one is 89, then this one next to it is 91 because they're all supplementary. The exterior angles are outside of the figure. If this is 76, then right next to it is 104 because they have to be supplementary. And if this is 124, the one next to it is 56. So now let's add up 56 plus 109 plus 91 plus 104. The sum of those exterior angles is again 360. So the sum of the exterior angles of a polygon, there is no formula, it's just 360. I don't care if it has 3 sides, 4 sides, 10 sides, or 20 sides. The sum of the exterior angles is 360. So what kind of questions can I ask? What is the measure of each exterior angle of a regular hexagon? Well, we know the sum of the exterior is 360. And I want to find each exterior angle. So this is a hexagon. A hexagon has 6 sides. So I'm just going to take the sum of the exterior angles, divide it by 6. Each exterior angle would be 60 degrees. Okay, not too bad. What is the measure of each exterior angle of a regular decagon? Again, the sum of all of them is 360. A decagon has 10 sides. So 360 divided by 10 is 36. And this last one here, if the exterior angle of a regular polygon measures 40, how many sides does a regular polygon have? I can do the exact same thing I just did up above. The sum of the exterior angles is 360. Normally I divide up above, I just divide it by how many sides it has. Here I'm just going to take 360 and I'm going to divide it by the angle, and 360 divided by 4 is 9, so it has 9 sides. So you're either taking 360 and dividing it by the number of sides, or